Today we will be discussing lesson 14.1, part 1. This will be talking about distance on the coordinate plane. Page 401 is where we will be today. So if you'd like to get your math book and pause the video, we will be on page 401. Okay, our standard for today is going to be standards NS8 and NS6. I can graph points on a coordinate plane, and I can reflect points across the x-axis and y-axis on the coordinate plane. So first I'd like to start with a few definitions so that we can be aware of what we are doing, and then I'll be doing some demonstrations. So let's take a look. First of all, definitions. So a plane is a flat surface. So you could have a rectangle. Draw a little rectangle here. The flat surface is the entire inside. And we, in our last unit, we're talking about the area of a flat surface. The next definition is a coordinate plane. A coordinate plane is a system that gives each point in a plane or a flat surface a set of numerical coordinates. And if you don't know quite what the definitions mean, we will be seeing those demonstrated out in a few minutes. The x-axis is the horizontal line on the coordinate plane. The y-axis is the vertical line on the coordinate plane. Remember, horizontal is this direction, vertical is up and down. The x-coordinate is the horizontal value in a pair of coordinates. It's how far left or right the point is from the y-axis. The y-coordinate is the vertical value in a pair of coordinates, or how far up or down the point is from the x-axis. Every point can be located on a coordinate plane by its x-coordinate and its y-coordinates. For example, you may have point 3, -2. It is 3 units to the right of the y-axis and 2 units below the x-axis. So we'll be talking about that, and I'll be showing you that now. Okay, we've got a piece of graph paper here, and I will put a piece of graph paper on the Google Classroom for this lesson as well, so that if you want to practice at home with some graph paper, you can do so. So let's make a coordinate plane. So I'm going to use my ruler here. Now we don't have to usually necessarily make it that huge, but we want to see what we're doing here. So now we would put numbers by each line. 0 is right here. That's the 0 line. I'm actually going to use a different color. I'll use pink. So this, you are familiar already with the x-axis. So let's write x. That's our x-axis. And this, up and down, is our y-axis. You're already familiar with this because if we didn't have this here, remember how we plotted points on a number line way back in September and October? You already know how to do that, and you know which direction the numbers go already. So that's good news. That's something you already know. We're going to add in a piece, how far up or down something is. So a point isn't necessarily always going to be on this straight line, right? A point could be up here, or down here, or over here, or over there, right? It can be all different places. So we need a way not only to say where it is on this direction, but we need to say where it is going up or down. So that's what we're going to be talking about. So we're going to put some numbers here, just like we did on a number line. And I don't know if I can squeeze those in. Can you see those? Yes, I believe you can. 4, 5, 6, 7, 8, 9. I'm just going to go to 10. Now, be careful. You want to put the numbers on the lines, not in the spaces. Very important. Going the other direction, remember how that goes? -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Hopefully you can read those numbers okay. Maybe if I zoom in a little bit. Okay, now we just have to add in some extra pieces. We have to add in the numbers up and down. So one direction are going to be positive numbers. The other direction are going to be negative numbers. What would you think? What direction would the positive numbers be going? Up or down? Exactly, they'd be going up. So we're going to label these 1, 2, and again, I'm labeling the numbers on the lines, not the spaces. 3, 4, 5, 6, 7, 8, 9, 10. And quite honestly, if we wanted to, we could go on forever and ever up to 1,205,000, 2,000,000, 2 trillion. We could keep going forever and ever up, and we could keep going forever and ever down. We could keep going forever and ever left and forever and ever right. The numbers never end. So here we have -1, -2, -3, -4. So down are the negatives. -5, -6, -7, -8, -9, -10. Okay, we have our coordinate plane, and I want to take a bright color here, and we are going to plot the point. See if you can see this. Up a little bit. We're going to plot the point 3, -2. Now that is called a coordinate pair. The first number is always the x value. The second number is always the y value. So if you think about in the alphabet, x comes before y when you sing A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. X comes before y in the alphabet. So x is always the first number in the coordinate pairs. So then we just have to plot it, and I'll use this color. So we have 3, so we're going to find 3 on the x-axis. Remember, this is the x-axis. So I find the 3, and it's on the line. And then my y value is -2. That's my up and down number. So I have to find -2, which is right here. Then I have to find where they meet. So where 3 and -2 meet. So I'm going to label that 3, -2. It's always a great idea to start learning now how to label your points with the coordinate pair next to the point. Okay, let's graph some more points. And if you'd like to pause the video and get a piece of graph paper out if you've got one, or you can stop for a minute and print it off on the Google Classroom, go right ahead and do that so you can plot these points with us. So I'm just going to kind of make this a little bit bigger if I can. So I'd like to plot the point 5, 4. And you can't see that, so plot 5, 4. So remember, the first number is our x value on the x-axis, and our second one is the number going up or down on the y-axis. So I have to find 5. So 5 is going to be in the positive direction. Here is my 5. And then I have a 4 for my up and down, my y-axis number. And then I have to find where they meet. So here's 4. Here's 5. Let's go straight across till we find where they meet. Get another color out here. So 5 up to 4. Put a dot right there. Label that point 5, 4. Okay, we're going to do another one. We're going to do -3, 1. -3, 1. If you'd like to pause the video and do it before I do, go right ahead. So here we go. -3 is going to be to the left of 0, right here. And 1 is going to be going up. So we have to find where they meet. They meet right there. That is point -3, 1. Now I'd like to do point -4, -3. So you see how we are not limiting ourselves anymore to just a number line. We are limiting ourselves to the entire space around that number line. So -4, -3. So -4 is my x value. I go all the way here, I find -4. -3 is my y value, and the negatives are going to be on the bottom part of the line. So -3 and -4 are going to meet right there. And we're going to label that -4, -3. So you notice we have 4 quadrants. They're called quadrants in a coordinate plane. This is quadrant 1, 2, 3, and 4. And we've labeled a point in each quadrant of the coordinate plane. How about this one? Where would this be? 0, 5. Where would 0, 5 be on the coordinate plane? Well, the x value is 0. So where is 0 on the x line? Exactly, right dead in the center. And where is 5 on the y line? Exactly, right up here. So 0, 5 is actually going to be right on the y-axis. That is 0, 5. Supposed to be a little arrow. And what about -10, 0? Where would -10, 0 be? -10, 0. This is our x value. It's going to be on the x-axis. Here's -10. The 0 is our up and down number. Well, where is 0 on the y-axis? Right in that, right on that spot. So our -10, 0 is going to be right there. -10, 0. Again, remember that the x number always comes first. Okay, I have another coordinate plane here. And on this coordinate plane, we are going to learn about reflection. Now think about the word reflection. What does the word reflection mean to you? Exactly. You may think of reflection as looking at yourself in a mirror. You may think reflection as looking at yourself in the surface of pond water. So a reflection is really a reverse image of yourself when you're looking at yourself face to face. So we are going to learn how to reflect points. We have the point 3, -2 down here, and we're going to plot that in a minute. And then we are going to reflect it. So we're going to reflect it along different parts of the coordinate plane. So let's see how that works. So I am going to take 3, -2, and plot that. Now I didn't want my numbers to be as crunched on this one, so I just counted 2, 4, 6, 8. But the in between ones are 1, 3, 5, and 7, all directions. So 3, -2 is going to be right between the 2 and the 4 on this line, and -2 is right here. So this is my 3, -2. So what I want to do is reflect, let me just mark that, 3, -2, 3, -2. What I want to do is reflect that along the x-axis. The x-axis is this one. So I'm going to reflect it, meaning I'm going to flip it and reflect it. So to do that, let's try, I'm going to make this real dark and see if this will work for us. And I'm going to fold it right along the x-axis here as best as I can. And see if it, oh, almost. So let's darken our circle a little bit, fold it. See if we can get that to reflect. Now I'm going to open it back up, and it worked. You can see that we have a point, and if I had folded it exactly perfect, we would end up on this spot right there. What is the coordinates of that point? Well, go here. That's 3. And where is it up here? Should be on the 2. So it's 3, 2. That point is reflected across the x-axis. Now let's take a look at that for a minute. How many units, take a different color here. How many units have I gone from here to there? 1, 2 units, correct? I have gone a total of 2 units. How many units have I gone from here to there? Here to there. 1, 2. Another 2 units. So if you notice, you can see that the point this will always be reflected the same number down as it is up, or the same number up as it is down. So here it's 2 below the x-axis. When we reflect it, it will be 2 above the x-axis. And if you notice, the x value doesn't change. It stays on the number 3 line. The only thing that changes is the number on the y-axis. And how does that number change? What's the difference between those two numbers? Exactly. The sign is different. So when you're reflecting across the x-axis, the point will always change signs. So let's give that another try and see how that works. Okay, I'm going to reflect another point across the x-axis. Let's label our axis again here, x, x, y, y, so we can remember. So let's put -3, -4 on our coordinate plane. So -3 is the x value. So it's between -2 and -4. So here's -3. -4 is my up and down. Well, it's negative, so it's going to be down. So we're going to go -3, -4. Actually, I wanted to use pink. You can see it, but I think we'll see it just fine like this. So now I want to reflect it across the x-axis. So I'm going to attempt to fold this. Probably hear my dog barking, because he barks a lot. I think I've said that in another video before. Not a lot we can do about it, but he barks, he barks. Okay, let's see if we can, trying to get it as close to perfect as I can. It's not going to be exact. And I got to color this in a little bit more and fold it and rub it so that it comes across. There we are. Here is our reflected point. What is that point? Well, that should be still at -3. What is the, didn't come out exactly perfect because of my fold, but it should be on the +4. So it should actually have come right about there. +4. My fold was a little off. Wish I had some whiteout that actually worked here, but no, it's all dried out. So this is where the point is, right here. -3, 4. A little hard to see, but not too bad. So that's reflected across the x-axis. Remember what I said. The distance from here to the x-axis is how many units? 1, 2, 3, 4. 4 units. And then the distance from here to the point is how many units? 1, 2, 3, 4. 4 more units. So remember that a reflected point will become, if it's 4 below, it will become 4 above when you reflect it across the x-axis. And remember what happens to the point. Let's compare the 2 points. We have the second point. This was our first point. We'll call this point A. And we'll call the second point A prime. That's another way of saying a reflected point. That little symbol means prime. That coordinate value is -3, 4. So again, what do you notice? What's different between the pairs, the ordered pairs now? The -3 stayed the same because we're still on the same line horizontally. I mean vertically, but at the same point horizontally. And our y value is the only thing that changed. And what changed between this one and that one? The sign changed, exactly. So the sign will always change. So this one started out negative and it became positive when we reflected it. This other one, bring that one back for a minute, that one started out negative and became positive as well. If we would have reflected it the other way, it would just switch. Okay? Okay, so I wanted to bring your attention to the rule that we have just spoke about and demonstrated. So here's the first rule. When a point is reflected across the x-axis, which is what we did, the x-coordinate, the first number, stays the same. We saw that. And the y-coordinate changes signs. So in our example, one of them was, we had the point, last example we just did, -3 comma -4. When we reflected it, it became -3 comma +4. So that's an example of the rule. So that's the shortcut to folding your paper and seeing where the point lands across the x-axis. You can determine it by knowing this rule. Okay, let's go back to the document camera. Okay, here we are back under the document camera. We're going to plot point 2, 6. Go back to my pink color here. 2, 6. So the x value is first. There's my 2. 6 is my y value. Where do 2 and 6 meet? They meet right there. Now what I want to do is not reflect across the x-axis. This time I want to reflect across the y-axis, the vertical line. So let's see what happens when we fold the paper the vertical direction. So let's see if you can see this. I'm going to try to color in that circle real well again so that it sticks. I'm going to try my best to fold it right on the line. It's not the easiest to do. I'm a little bit off, so I think my point will end up being a little bit off. Let's color it in again a little bit. And rub it in there. See if it comes out right. Okay, what did we get? Here's our reflected point across the y-axis. So it should be, it's a little bit off. Should be at right here. Should actually be right there. My fold is not that easy to keep straight. So this is where it should be. So let's write the coordinates. This one was 2, 6. What's this one going to be? Well, we're at -2 and we're at the 6th line. So that's -2, 6. Okay, what do you notice about the difference in the coordinates between 2, 6 and -2, 6 when we reflect it across the y-axis? Well, you should notice the 6's are the same. It's still going to be on the same line this way, but look what happened here. These two have now switched signs. So before, when we reflected across the x-axis, the y-coordinates changed signs. Now we're reflecting across the y-axis, and the x-coordinates are changing signs. Okay, let's see if we can do another one on this paper. Let's do -4, -5. So -4, yeah, let's use pink again. Now let's try, yeah, no pink. Can't make my mind up. -4, -5. right here. This is -4, -5. Here we are at the -4, and we go down to where the -5 meets it. Now I'm going to try to fold it across the y-axis because we want to reflect this across the y-axis. I'm going to try to fold this one a little bit better here. I'm actually going to start by folding it this way, so that way I can see the line exactly. Just see what I got here. If I do this, it might work out a little better. Okay, now let's fold it in the other direction here. Go on the right crease this time? I don't know. Try to get it on the right crease. Let's just see. All right, hopefully this works. Let's see what happens. So I'm going to color in that real dark, and then I'm going to fold it over on the line, rub it a little so it reflects. And I'm going to open it up, and there it is. It's there. You can barely see it, but it's very faint. And that point should be on the -5, which it is, and the +4. So that one almost worked out perfect. So that one is +4, -5. Comparing the 2 points, this is the original, this is the prime or the reflected point. The only thing that changed, the -5 stayed the same, the y value is the same. The sign switched for the x values. Okay. I want to point out the unit difference as well. So we started out with 2, 6. How many units did we go to the line? 1, 2. So 2 units. You see that? And then from here to the next point, we went 2 units. So when you reflect across the y-axis, the point goes the same number of units from the right side of the y-axis to the left side of the y-axis. Down here, we were 4 units away. 1, 2, 3, 4 units. And then from the y-axis to the next point, we were 1, 2, 3, 4 units. Again, you should be the same number of units on the other side of the y-axis as the point was initially. Okay, we want to look at our reflection rule. So I'm going to bring down my spotlight here. So we have this rule for when we cross the x-axis and reflected. This is the rule for when we reflect across the y-axis. When a point is reflected across the y-axis, the y-coordinate stays the same, that's the second number, and the x-coordinate changes signs. So we had used, one of our points was 2, 6, and when we reflected it, you can see that this way, across the y-axis, we ended up with -2, 6. So notice how it changes. That's a little different than when we reflected across the x-axis, because then the y value changes signs. When we reflected across the y-axis, the x value changes signs. Okay, I'm going to show you one more thing. Okay, I have a question for you. What happens when a point is reflected across the x-axis and then reflected across the y-axis? So let's pick a point. I'm going to use the point 3, 5. So 3 up to the 5 line, point 3, 5. And first, I'm going to reflect it across the x-axis. Can't see that, so let's move it. So remember, we're going to reflect it from here to there. So we're going to like fold our paper, I'm just not going to fold it this time. I'm going to see if we can do it without it so we can have the visual. So let's see what happens now. So we are how many units up from the x-axis? We are 5 units up, right? So we can count that. 1, 2, 3, 4, 5. So we are 5 units till we get to the x-axis. And now we're going to reflect it across the x-axis. So how many units down below the x-axis are we going to be? Exactly, 5 units. 1, 2, 3, 4, 5. So it's going to be 5 more units. And we're going to stay 5 units on the same x value. So this is on 3. So we are going to stay on the 3 line. So what is the coordinates of this point? Exactly, it's still 3. What's changed? We reflected across the x-axis. It changes signs, right? From 5 to -5. But we're not done now. We also need to reflect the point across the y-axis next. So now we're going to go this way. So we have to move the point that direction. So how many units is the point from here to the y-axis? Well, let's count. 1, 2, 3. 3 units. And that makes sense because 3 is our number, isn't it? Isn't that the x-coordinate? And then we have to go how many units this way from the y-axis? Exactly, 3 units. 1, 2, 3. So 1, 2, 3. And we want to stay on the same y value this time. So we want to stay on the -5, but we want to be at 3 right there. So that point is -3, -5. So remember what changes when we cross the y-axis? Oops, you know what? This is supposed to be -3, -5. No, +3. What am I doing? Okay, that's positive. Never mind. So what happens to the values? The x value changes signs. The y value stays the same when we reflect across the y-axis. So kind of a double whammy there, so to speak. We went down and then we went over. And we could keep going if we wanted. We could go up again this way, right? And where would we end up? So you can see how you can do different scenarios to see how that works. Okay, we are back, and I just wanted you to meet Willie. I don't know if I showed you Willie. I showed one of the classes Willie. I think it might have been the 8th grade, but this is Willie. Say hi. Hi, Willie. Even if you saw him before, he's so cute. He's worth seeing a second time. Okay, Willie, good job. All right, so let's go back to screen sharing here. So we have come to the point where we are going to talk about the homework for today. So we are not ready to do the actual page in the book yet. We had to do a little preliminary stuff. So what we're going to do is complete plotting and reflecting points on the coordinate plane, which I've put onto Google Classroom, and it's called lesson 14.1 part 1, because there's going to be a 14.1 part 2 in the next video. So that is your homework, and we'll see you next time. Bye. Have a good day.